I think I'll just start off slowly. 5 minutes I'll take.
Correct.
Good morning.
We have some more participants.
Good morning, Mr. Gopalkrishnan, and good morning to Mr. Mrityunjay Kumar also, who has joined us, and all the participants who are logging in slowly. In fact, after this is as part of the Engineers Day celebrations 2020 that we are having one more talk by Mr. Gopalkrishnan on a very important topic on non-destructive evaluation of reinforced concrete structures with emphasis on non-destructive testing methods. So last Saturday we had a program with the engineers of Odisha during the Engineers Day celebration, and prior to that we had with engineers from Karnataka. So that was the series of programs that we had arranged during the Engineers Day celebration, and I'm sure that this series of talks would be useful to all the participants. And those of you who are on Facebook also, I extend a warm welcome to all of you. And as much as possible, if you have any doubts or queries, please put it in the chat box, and we would be taking it towards the end of the session after the presentation is over. So just a brief overview of what we have been doing in the recent past. As all of you know, that Ramco Cement has been organizing this series of webinars to ensure that all of us follow good construction methods. That is what, irrespective of whether whichever material we use, but what is the role of good construction practices? That is what we are trying to look into. And in that aspect, we had covered a lot of topics, ranging from blended cement to concrete mix design to reinforcement detailing to smart city to various other issues that the construction professional faces at site or maybe at the design level. And I'm sure that even for the student community, those who are logging in and are interested in cement, concrete, admixtures, reinforcement detailing also should make use of this series of talks. I'm sure that many of you would get a better perspective from various speakers, because each speaker is having his own experience, which I'm sure that we would be able to take it up. So Ramco Cement's this thing of right product for right application, we have been introducing various types of cement. That is, we have almost 12 brand of cement, out of which 4 are PPC, 2 are PSC, and others are 4 are OPC, and 1 SRC cement, and 1 Ramco Superfast cement. So the idea is that based on the application, we are trying to have each cement. Like say, for example, Ramco Supercrete cement is a PPC cement which has been introduced specifically for concreting works, and it is having a high strength as well as low heat of hydration. So that is the kind of thing, because we found that many of them wanted a faster setting time also while concreting is done. So that is the reason we have fine-tuned certain properties, and at the same time, when you have a higher rate of gain of strength, there is a possibility that heat of hydration would also be higher, as in the case of OPC. But we have tried to fine-tune that in Ramco Supercrete cement. Then we have the Portland slag cement, Ramco Samudra, and Ramco Super Steel, which are again, as all of us know, in aggressive environment for underground structures, and wherever sulfates and chlorides are there, it is being used. Of course, with the ordinary Portland cement 43, 53 grade, we have 43 grade infra as well as 53 grade infra, just to ensure that concrete is having a high slump retention. Then we have the sulfate resistant cement and Ramco Superfast cement, which is again for precast items. So those are the type of cement that we have got. And of course, we have the dry mix range of products. So we have a dry mix plant at Sri Perumbudur, where we are using various polymers and additives to ensure that customized products are being manufactured. We have the Ramco Tile Fix, Ramco Super Plaster, Ramco Block Fix, Self-Curing Plaster, Tile Grout, and Superfine. So those are the dry mix range of products that we have got. Of course, we have got good interaction with various construction professionals. We have been associating with them with various projects like L&T. L&T is also executing our a new plant at Kurnool, as well as they have also completed our grinding unit at Odisha. So that's how we are able to supply cement to projects which are exposed to different exposure conditions and which needs different requirement. That is why we always appeal to the construction professionals, is that we need to understand what concrete we are going to use. Rather than limiting ourselves to the grade of concrete, we need to go into the detail also. Like what is the workability that is required, what is the durability, can we measure the durability, because there are so many durability evaluating instruments that are available nowadays, like RCPT test and water permeability test as per DIN standard. So those equipments can be made use of. And then we have ITD cementation again, where we are associating with various infrastructure projects. So of course, Bangalore Metro Rail Corporation as well as other metro projects, our brand is approved, and various projects in the eastern part of the country we are catering to. So that is the kind of this thing that we have got. And we have got a research center at Chennai, because R&D being an important element, because we have seen that many construction professions are facing problems at site. So what we do is that we do number of concrete mix designs at our R&D lab, and try to help them out. And apart from testing various materials, raw materials, various types of cements, and giving suggestions on how to make good concrete. Of course, the Four Leaves Award, which we have been we have got for leadership in technology and energy efficiency, utilization of blending materials, and for those initiatives, we have got this award. So those are the kind of things we thought we will share with you. And I do not want to take much of your time. Just to give a brief introduction of the speaker of the day, who has agreed to talk on a very important topic, because all of us know that we have a number of interpretation as well as non-destructive testing is concerned. So we have Mr. E.E.GOPALKRISHNAN, who is the head of Advanced Diagnostic Laboratory and Consultancy Services of Dr. Fixit Institute of Structural Protection and Rehabilitation. He is working as head of Advanced Diagnostic Laboratory and Consultancy Services of Dr. Fixit Institute of Structural Protection and Rehabilitation, which is promoted by Pidilite Industries Limited. He has more than 30 years of rich experience in construction field, and is involved in execution of infrastructure projects like highways, hydroelectric power, and Delhi metro projects with Swedish multinationals. Established Advanced Diagnostic Laboratory, NDT, Chemical and Petrography of Dr. Fixit Institute of Structural Protection and Rehabilitation, Mumbai, and got an accreditation from National Accreditation Board of Laboratories, NABL, New Delhi. Empaneled as lead auditor as per ISO IEC 17025 and ISO IEC 17043 for NABL. He played a lead role in completion of structural audit of various industries such as cement plants, power plants, fertilizer plants, and paper mills, including their repair and rehabilitation. He has authored several papers on utilizing fly ash in high performance concrete, sustainability of green concrete, repair and rehabilitation and waterproofing of structures, and conditional assessment for so he has presented so many papers for structural repair and rehabilitation and advanced repair materials, systematic approach to post-earthquake repair and rehabilitation of structures, published at Nepal Engineers for National Institute of Construction Management Research. And he has also published on renovation of building and maintenance management, and he has given a number of lectures on conditional assessment using advanced non-destructive testing techniques at Indian Institute of Technology, Madras, etc. So he is having a lot of experience as far as various projects are concerned, and I'm sure that construction professionals who have logged in, I see almost 72 have logged in now, would utilize this opportunity to interact with the speaker. And as I was telling, that you can always share your opinion, your feedback, your questions, and have a very fruitful discussion and make the best use of this talk. Over to you, Engineer Gopalakrishnan, and thanks for accepting our invitation. Thank you so much.
Yeah, thank you thank you very much for the introduction. Let me start. Thank you for the introduction. I given it takes a lot of time anyway, but you have given me opportunity to talk about this subject, which is always debatable. Some of the cases there is opinion, always there is a different idea, different conception happening on this area. I am going to talk about today what is the advanced non-destructive testing used for assessing the reinforced concrete structures, and what way it helps to benefit the engineer society today. As a structural engineer, we need to the buildings, because nowadays there is a assessment is very much needed to do the proper maintenance and repair those areas. Let me talk about subject. We will be having a 1 hour exactly. Where I do of Section Rehabilitation is a not-for-profit company registered under Section 25 of Indian. Mission is to become a knowledge and skill development center in repair, waterproofing, and other area of renewable engineering. We are offering service for structural repair, restoration, waterproofing, and distress assessment of which is created in Mumbai our head office. What are the collaborative arrangement? We are having a network with the national as well as international. Like national, we are having ICI and other engineering consultants chapters. Beside that, we are having international association with the International Concrete Repair Institute USA, and we a New York Roofing Contract Association of USA, Concrete Institute of Australia, Concrete Society UK. We share the knowledge and we share the technique, what is developed, what is latest on today, and even we invite the expertise to assist us in a special projects or deliver some technical topics where our fraternity also getting advanced knowledge what is happening across the globe. Without taking much time, I will explain that what are the services we are offering to the industry. One is that we conduct a structural audit, conducting a comprehensive structural audit of building with the advanced non-destructive equipments, and also giving the rate analysis with a budget for the repair scheme. And we provide services to various structural consultant and other agencies. Normally, whatever we do in the common entity test and also partially non-destructive. We conduct a petrography examination of deteriorated concrete. The non-destructive testing only it will not give many information, so that the petrography information will give the fire damaged concrete structures or deterioration, the reason for deterioration, whether the matrix of the bonding is proper or not, what is the mineralogy of the material used, everything we can able to identify through the petrographic examination. Also, we provide thermography survey. Thermography survey mainly used for the building diagnosis. We try to understand the defects of the building as well as particularly understanding the source of the leakages to try to take a remedial measure on this. So this all the survey explain to you. Today, what we'll be discussing today, one is the service life and durability factor which affect the buildings. Second one, why non-destructive evaluation is required? Because many of us having a doubt still when the construction is done with a good quality, better workmanship, why we need to have the evaluation? So we are going to discuss about that. Third one, different step of condition assessment of the structures and advanced non-destructive testing techniques, how benefit, and include some of the case studies where I have seen that some interesting the cases which I want to share with you so that we can able to complete our topic today. The service life of the material can be assessed by the expected lifetime or their acceptable period of usage. For a long time, the concrete was considered very durable material requiring little or no maintenance. However, many structures around the world have shown the deterioration during the past 60 to 70 years. What is the reason? Based on the exposure condition, structures deteriorate. Different structures are having a different service life. For most of the structures do not attain their service life because of poor maintenance. When you're talking about service life, without any major maintenance or repair, the building has to stand for the functionality. That is the service life. What are the factors? As per the IS 456, the durability concrete is one of the performed satisfactorily in the working environment during the anticipated exposure condition and during its service life. That was a definition given in IS 456. Durability, again, it's going to affect different parameters like carbonation, chloriding risk, alkali silica reaction, freeze-thaw action, which is not applicable to our country. Durability mainly related to the corrosion, chemical attack, alkali silica reactivity, delay gelatinous formation. And we can say that the multiple transport mechanism which is, the hazardous chemicals like chloride, sulfate, or gases entering into the structures along with the moisture, it starts the formation, corrosion, etc. And the second point, selection of raw material. That is also very important, including the mixes and criteria to meet the durability requirement. Also, we rarely check the as a structure specimens. We check the part of the sample collected and maintained at the cube, controlled environment. So that is also performance-based durability. We should think about that. Besides those factors, some relate to the concrete quality, such as water cement ratio, cement content, impurities in the concrete ingredient, presence of sulfur attack, and cracks related to the exposed environmental conditions such as moisture, oxygen, humidity, temperature, bacterial attack, stray currents, which affect the reinforced corrosion generally. But in spite of all the precautions and preventions, concrete deteriorates in severe and extremely severe exposure conditions. So, while the root cause of deterioration need to be ascertained, now I am going to show you the schematic stages of corrosion-induced deterioration of the concrete structures. In this one, I can bring out what is the corrosion mechanism or deterioration mechanism. There are the four stages given here. The first one is depassivation of the steel reinforcement due to the external environmental influences. But at this point, corrosion is possible, but there is no observable or actual physical damage as we can observe in the first stage. Moving to the second stage, the development of corrosion, which occupying the volume of significantly larger than the original steel. The induced tension is in the cover concrete leads to the cracking. But what is the, when the steel bar occupies volume of 3 to 6 times, more than 6 times of the original steel, definitely the cracking happens to the cover. The stage 3, widening crack facilitates the penetration of moisture and aggressive substances into the concrete, promoting faster rate of corrosion, eventually leading to spalling of cover concrete. This has happened in the stage 3. The corrosion progress at increased rate, resulting in more spalling of concrete cover and increasing loss of cross-sectional area of embedded steel reinforcement. This leads to significant reduction in strength of affected members, which may significantly lead to their collapse. This situation required urgent intervention. So, initial phase, we need to observe. We may not be able to take any action. But propagation phase, yes, we need to understand. We need to diagnosis with the use of non-destructive techniques. What is happening? What is the corrosion level? Whether it's severe or it is in the early stage of mild or medium, we need to ascertain the stages. For understanding, I'm going to run one small audio visual here.
Corrosion is a process or chemical reaction where refined metals such as steel and iron return to their more stable combined forms as oxides, carbonates, or sulfides. In this chemical reaction, a section of the steel material acts as an anode. This means that the steel loses electrons. On the other hand, another portion of the reinforcing mesh acts as a cathode. In the cathode, oxygen combines with water and electrons to release hydroxide ions. This shows that the reactions require both water and oxygen to occur. The volume of corrosion products, especially Fe2O3, is significantly higher than the original steel. This will increase the internal pressure and consequently crack the concrete. We know that the availability of these three elements are essential for corrosion to happen. The reaction requires water and oxygen. However, experiments in real case scenarios show that chloride plays a key role in the onset of corrosion. Concrete provides a high alkalinity environment around the reinforcement. In normal conditions, one can expect this will protect the reinforcing bars from corrosion. At the same time, we know that concrete is a permeable material, as moisture and aggressive ions can move through the pore structure of concrete. The interesting question that arises here is the role of chloride ion in this reaction. This has been the topic of research for many corrosion specialists around the world, yet there is no definite answer to it. A very basic explanation is that the ingress of chloride destroys the protective oxide layer on the surface of rebar. This eventually destabilizes the protective film over the reinforcement, which eventually leads to the initiation of corrosion. As I mentioned earlier in this presentation, the porosity of concrete makes it possible for ions to penetrate into concrete and make the concrete itself act as an electrolyte. Corrosion happens in this environment, and the movement of electrons in concrete creates an electrical potential field inside concrete over the surface of rebar. For example, the reactions in the anode, where steel loses electrons, can create a potential difference of negative 780 millivolts compared to a standard copper sulfate electrode. The cathodic reactions would result in a potential difference of positive 160 millivolts. The traditional way of investigating corrosion is visual inspection. However, when damage is detected in visual inspection, it is already too late. Signs of corrosion are often marked with delamination, which is the result of corrosion materials expanding. Visual inspection is often performed with chain dragging tests to identify the delaminated areas. At this stage, there is not much left to do except repair. Corrosion activity is often to corrosion study. The first concept is the half-cell potential. In this method, surface potential measurement is used to predict the probability of corrosion. While the test provides useful information about the chance of corrosion for the area under investigation, the results can easily become misleading if the potential effect of influencing parameters are not appropriately taken into account. Another limitation of the test is that it does not provide any information about the kinetics of corrosion reactions. The second concept is the rate of steel corrosion. The corrosion rate is about the kinetics of reaction and how fast the corrosion is progressing in the concrete. This becomes important in the context of life cycle assessment, as it helps engineers better predict the remaining service life of a given structure. So let's talk a little about these concepts and measurement test methods. The half-cell test can be used to predict the corrosion potential from the surface of concrete. Several associations have standardized the test procedure, including ASTM, UNI, and RILM. In the half-cell potential method, the potential values at the surface of concrete are measured with respect to a reference point. Concrete surface should be prepared before doing the test, that is to remove paint or other non-conductive layers from the surface. The surface should have a minimum amount of moisture. A sound electrical connection should be established between the reference electrode and reinforcement. The value is normally presented in contour plots, showing different half-cell potential values. This helps identify areas with a higher chance of corrosion. For example, ASTM C876 introduces 3 different ranges for the measurement. Half-cell potential values less than negative 350 millivolts, measured in reference to copper sulfate electrode, represent an area where probability of having active corrosion is more than 90%. When measurement is higher than negative 200 millivolts, this probability is less than 10%. Results for half-cell potential values between negative 200 millivolts to negative 350 millivolts is uncertain.
Yeah. We have seen that what is the corrosion happening and how it's affecting to the structures. Now let us see the assessment of the structures today. There is the different type of assessment. Strength assessment to assessing the concrete strength, durability assessment to identifying the nature and extent observed or suspected deterioration into reinforcement corrosion. So integrity assessment, determination of localized integrity of the structure or generalized assessment of behavior of old structures. The old structure we can assess, we can say the integrity of the structure, what is the status of the condition, etc. There are 5 steps of condition assessment. One is we conduct a detailed visual inspection. What is the deterioration shown that? What are the cracks? What is the different deterioration happening to the structures? And the second one, based on the visual inspection, we identify what is the NDT required. NDT is always group of NDT test. to give the information about the structure which is not visible. So some of the entity tests and partially destructive tests also conducted, like taking a core and other tests which is partially damaged. And whatever the collected sample, we'll be conducting some of the chemical analysis and conducting a lab test and interpreting the result of non-destructive evaluation. Finally, we make the report, prepare the report with a recommendation, including the severity of the deterioration and what is the strengthening measurement required. With the, in totality, with the rate analysis, we submit to the customer so that the client come to know what is the problem and what I am going to do, what is the budget I have to allocate for that. So everything is there, they can able to successfully repair that particular structures for extending the life of the durability. Okay, this is all the condition assessment. Let us go to the non-destructive testing. Recently, non-destructive test is most frequently used for evaluation and condition assessment of the building. The non-destructive evaluation of civil engineering structures in reinforced concrete is becoming an increasingly important role in this field of structural engineering. Plus, the integrity or a material or conducting health assessment, we use several non-destructive testing. I'm going to explain you. We will review the potential options and the practical solutions for an on-site evaluation of the concrete strength or RCC structures. The rebound hammer, you all know, it is one of the very simple and low-cost test, which is most widely used in the non-destructive test of the concrete. Like the principle, you know that if you hit the, surface, ordnance surface, you get a higher rebound number. When you're having the smooth surface or a soft surface with the porosity, you get the low rebound number. The operation is shown here, so I'm not going to take much time on this. So when you get the reading, we can able to see the rebound number on the sliding scale, so that we can report the rebound number. Okay. So the chart and tables provided in the instrument should not be used for absolute estimate of compressive strength. The traditional rebound hammers, we need to correct the angles, horizontal, vertical down, vertical up, to have the correct rebound number values. It depends upon the stronger surface. I mentioned that you can get the higher rebound number because of the indentation, and weaker surface giving the lower. Normally, we take the average of 6 readings and report as a rebound number, because it's affected with the several factors: surface condition, presence of rebars, and presence of subsurface voids can affect the result. Even the carbonated dry surface can get a higher rebound value compared to normal. We need to understand while interpreting the results. Just I'm running the video so we can.
In this video, we'll be covering a quick review of the rebound hammer testing method. Since its introduction in 1948, the rebound hammer has become extremely popular, mainly for its simplicity and ease of use. It is an inexpensive and quick method for non-destructive testing evaluation of concrete hardness. The main applications for the rebound hammer are to assess the in-place uniformity of concrete and to estimate the in-place strength of concrete if a correlation is developed. In order to test, the plunger is pushed against the concrete perpendicular to the surface. As the hammer body is pushed towards the concrete, the force causes the latch to release and make an impact on the concrete. Essentially, the rebound is after its impact with concrete surfaces. The output of the rebound hammer is then referred to as the rebound number, and this is correlated with the surface hardness of concrete. A higher R number means higher concrete hardness. The rebound hammer can be placed in many configurations, including upwards, downwards, at any intermediate angle, and horizontal. Inspectors should pay attention to the following considerations prior to conducting a rebound hammer test. The testing surface should be at least 150 millimeters in diameter. The surface should also always be smooth before testing. If there is any free moisture or water on the concrete surface, it must be removed. And finally, it's important not to test on frozen concrete. And concrete should only be tested after it has thawed, since frozen concrete tends to have high rebound numbers. Although the rebound hammer provides a quick, inexpensive means of checking the uniformity of concrete, the results can also be affected by the following parameters: smoothness of the test surface, size, shape, and rigidity of the specimens, age of test specimens, surface and internal moisture conditions of the concrete, type of coarse aggregate, type of cement, carbonation of the concrete surface, and type of mold. With recent advancement in sensor technology and development of wireless communication, a new generation of rebound hammers are commercially available. Recording and tracking job-specific details, including hammer angle and on-site verification of test results, was time-consuming and prone to errors. The new generation of hammers help engineers get around these issues. For example, new generation hammers apply real-time checks on the quality of datasets and do not need to be adjusted for the configuration of the hammer. In this video,
we heard about that. There is a new generation hammers because everybody is familiar since it's a basic test. There is a silver summit, which is a new latest development, which gives the Q value. There is a difference between R value, which you used to get in the conventional instrument. So the same concrete, the Q value is not equal to R value. What is the difference? The new technology measure the Q value. Q value we measure the rebound velocity optically, whereas we measure the rebound distance mechanically in the R value. So it is not affected by the gravity. So more sensitive, give the higher limits, lower and upper limits. You can able to see the testing range 2 MPa to 100 MPa. Okay, this also digitally displayed and downloaded through the Wi-Fi and wherever you are. Okay. When you say that comparison of the latest one, both are correlate to the compressive strength. However, the original Smith hammer can measure 10 MPa to 70 MPa, whereas the new one, it can measure 5 MPa to 100 MPa. So, increasing the lower and higher limits by 50%. Now, what is the coefficient of correlation? 0.84 for the silver summit, and we can see that latest Q value will give the 0.97 coefficient correlation compared to the R value, which is 0.84. Okay, so overall, this rebound hammer minimize the total number of force taken, so that we can able to assess the quality of the concrete, and also it ensure that when you are collecting the samples or reconstructive and investigative sectors, so that we can get the correct information. So this we can able to do very quickly and non-destructively using the rebound. The limitations are there. We need to assess the surface hardness only, and it is give the high accuracy result when you are having the reference curve, or from the core samples we can get more close prediction on the compressive strength. Next one, the ultrasonic pulse velocity is another interesting one. It working in an effective method for the quality control of concrete material and detection the damage in the structural component. See, this has been used traditionally for quality control of material, mostly homogeneous materials such as metal welded connection. With the recent development, the transfer technology, the test has been widely accepted in testing of concrete material also. The principle you all know that the usually in a concrete element, we see that uniformity of the concrete and understanding the detecting the damage in the structural component. The ultrasonic testing concrete is an effective way for quality assessment and uniformity, and also it can be used for crack depth estimation, which I am going to talk about today. The principle is through the transmission time and measuring the distance between the probe, give the distance by the time travel, give the velocity reported in a kilometer per second. It's used to detection of voids, cracks, and other internal imperfections or defects. It's estimating the mechanical or structural properties of material, porosity, density, strength, or elastic modulus. There is a different type of testing arrangement: direct, semi-direct, surface probing. Surface probing is not an easy thing to interpret. Only the advanced users can able to interpret the surface probing results. Presence of defects increases the travel time and resulting lower computed speed. Like honeycomb is there, the time travel is higher, so that you will get the low velocity. When crack is there, definitely it is not going to show, or it will not give any reading at all when the crack is thrown through. So we need to understand about the defects through this testing. As per IS 516, the latest revised code, above 4.4 km per second is excellent, below 3 is poor. Now we can see the two high quality concrete, the surface is smooth and high dense. It gives the high pulse velocity above 4.4 km per second. The poor quality, where the voids and honeycombs are there, it gives a lower than 3.0 km per second, which is poor quality concrete, for example. Its application is not only pulse velocity determination, it can use for the quality assessment, homogeneity, uniformity of concrete, and the measuring surface crack depth, prediction of compression of concrete. We can use it to understanding these parameters. The evaluation of crack. Usually, the cracks are used to assess the severity of the cracks, whereas crack depth used to evaluate the overall structural integrity of the element. So one is that understanding the crack, when we use a simple crack width measuring scale, we can able to see what is the crack width. What about the depth of the crack? Crack depth measurement can help repair contractor in evaluating the repair cost, and also even the site engineer rely on the different institutional method of non-destructive testing to estimate the crack depth. There are two methods used. This is a way we can able to measure the crack depth, covering the transit time between the above the crack. We can say the travel time to distance B and 2B. We use this formula. For a better understanding, I can able to show one audio visual. You can understand it much easier. One approach simply extracting the core and visually examine the core holes and core for possible cause of the crack. In another method, we use NDT, like ultrasonic pulse velocity, to understand or measure the depth of the crack.
Or determining
now,
used for
crack. You can able to see.
We're just going to have a quick look at determining depth of crack in concrete.
Able to see.
Probe.
We are able to see.
Probe is used here to measure the depth of the crack. Let us have a look at it.
Measurement mode. Now, there's a number of selections here, because we've selected crack there, so we're already in that mode. Here's the dimension B, which is 10 centimeters, 100 millimeters. The
100 mm from the
how
crack.
Far we are either side of the crack, and twice that. So this is 100 millimeters and 200 millimeters, or 10 centimeters and 20 centimeters. There's our 10, 10, 10, 10, etc. So I'm just going to put some coupling on the ground in line with this. Let's put a coupling, and a bit of coupling with those spacings. Now I need to make the first measurement here. I'm going to put the two transducers, one transducer there, one transducer here. They're not actually on the tape, they're just next to the tape.
I think you can able to see how the transducer is placed.
First I'm going to hit play. Here, this is auto mode, where it automatically jumps and automatically finds it, etc. Now I'm going to just move that, because I can see quite clearly that the signal is actually received. It's actually there. So I'm going to select that. Now, next thing I'm going to do now, I'm going to jump to the second set of measurements. So I'll move my two transducers there.
Yeah, we can move to further away.
And one.
Take parallelly.
There. Now,
two measurements.
We now hit this play button again. Now, this isn't jumping. Oh, sorry, hang on. I just hit something by accident there. I've need to go back out. I hit zoom in and hit that plus button. So I'm going to set it back to auto mode. Now, it's jumped to that spot, but I can see quite clearly that the nice clean sine wave starts a little bit earlier than that. So I'm going to move it back, and I can actually see the sine wave is really just starting there. I can see that pretty clearly. So now I hit finish on that, and it's got a crack depth of 44 millimeters. So it's that simple, that quick to find your depth of cracks in concrete. Nice little instrument. Thank you very much for determining that.
So the crack depth are not typically uniform throughout the length of the crack. You can see there is a zigzag pattern. So we need to measure different intervals so that we can take an average to understand the crack depth of particular crack. You can see that there is a different point. We are measuring at each point so that we can have an average. It will represent that particular crack. Measuring that, there are in this picture we can show that there are the crack 1, crack 2, crack 3. The depth is measured 2.11 mm, 1.12 mm, 1.52 mm, so that we can understand what is the depth of each crack, which will help to understand what is the remedial measure we are going to take, how to repair it, what kind of repair material we are going to choose, how we are going to complete the application of that. Now, second one, we are talking about the performeter, which is usually on the current principle. Measure the cover, also detect the rebound diameter and locations. So this is one of the measurement we can make it where there is no drawing is available. We use the performeter to identify what is the rebar position and what is the thickness, size of the rebar, which will help definitely to even give the protection to the structures without cutting it open. So advantage is it can measure the accurate cover and the estimation of the rebar diameter. What are the limitations? There are limitations. Yes, the top layer only can be detectable. The consistent areas we may not be able to identify what is the exact thickness. These are limitations we should understand. So when you are measuring that, the bore size need to be known within the plus or minus 1 mm bore size. And how to keep the substrate of the equipment directly over the bore, aligned parallel to the bore, not close to the parallel to the neighboring bore or not over to the near transverse bore. It will give the misleading results. So in this picture, you can able to see this one. First one is perfectly okay. Rest of the things is not okay. It is not going to give the correct results. It will pick up the adjacent bore also. So we have to be careful for measuring this. The next one, when you are doing the assessment of the structures, we conduct the coordination, which is a very simple test. So whether the coordination level reach to the reinforcement or what is the depth of the coordination. So simply we do use the phenolphthalein indicator, try to do that, and also check the pH and the chemical as a chemical method, whether it's status of the coordination started or not. This will help to strengthen the finding through the coordination. When the pH drops below 8.5, the passive iron oxide film breaks down and rapid corrosion occurs in the process of moisture and oxygen, as you know. So we are trying to measure the coordination. Like when you take the core from the particular structures, we can measure which is the color is turned, rest of the area shows pink. From the surface, we can measure what is the depth of carbonation from the surface, and we report. The important aspect of the corrosion. The corrosion is commonly observed in existing reinforcement concrete structures. When performing structural or condition assessment, engineers need to find proper answer to the questions. What kind of questions? One is, what is the current state of structure? What is the rate of corrosion happening? Or what is the remaining capacity and service life? it all depends upon the corrosion activity. We use the corrosion measurement using this GP 5000. It gives the option potential reading as well as the resistance measurement to find out the possibility of corrosion and also to find out the rate of corrosion. So these are the information we can get. Here in this electrode, normally optical potential electrode, we use a copper sulfate solution. Here we are using silver chloride, which is more accurate assessment can be made. So we are measuring the corrosion rate or optical potential of the reinforcement embedded concrete. The technique what you are using, the post-polarization technique method, the actual corrosion rate and the time of testing we can able to find out, so that we can able to assess the time to time, what is the corrosion, what is the increasing rate of corrosion. We can able to take the actual repair plan or protection plan based on the understanding the rate of corrosion. This is an instrument which is Gallo Pulse, which is having the handheld computer as well as having the God ring, which is you can show on the right hand side. As I said that this three information, the optical potential, corrosion rate, ohmic resistance, determined in one operation, single operation, you can get all the three information. Basically, the Gallo Pulse can tell you how much corrosion you have now and the potential for corrosion in the future. We can able to understand. This measure the corrosion rate and optical potential. Based on that, we can predict the lifetime of the structure. We call it residual life of the structures. We can take proactively extend your services lifespan when you are protecting the from the corrosion. Okay. So the key parameters involved in the corrosion of rate estimation include the concrete material, rebar condition, humidity, and temperature. Using all this information, lifetime prediction of the concrete can be made. What is the corrosion current, microampere per centimeter square? We can correlate to the corrosion rate, micro meter per year, and corrosion level, whether it's a passive, low, or moderate, and high. If it is a time to visible deterioration over 10 years, 3 to 10 years, less than 2 years, and the corrosion current is over 15 microampere per centimeter square. So this technique uses the linear polarization resistance, the relationship between the changes in voltage, the changes applied current per unit area electrode. This ratio called polarization resistant RP. The formula given, the I4 is B by resistance polarization. B is a constant, the RP is a polarization resistant. We can use the formula. The steam carry corrosion rate relationship, I equal to B by RP. Is microampere per centimeter square. The B is typically 25 to 50 millivolt. Using this Faraday's law, we can translate what is the I code. 1 microampere per centimeter is equal to 0.012 micrometer per year. In this one, we can able to understand what is the predicted corrosion rate going to happen to the structure. When we get the readings from the different grid of the element, so we can able to plot the contour map showing the corrosion rate, where significantly orange color shows the higher and the blue color shows the lower one. The option potential, although similar way, the yellow and the red one, it's orange, yellow and orange is giving the higher side and the rest of the thing on the lower. Ohmic resistance. So we can able to understand what is the corrosion rate, option potential differences, as well as the amount of resistivity present in the particular structures. There is a ASTM C806. It's giving the interpretation. It's saying that severe corrosion means less than minus 404 millivolt. The same way, there is a low corrosion risk, 10% probability. It is higher than minus 414 millivolt. sorry, 104. It should be higher than 104 millivolt. It is having a 10% probability of corrosion. For the resistivity, kilo ohms per centimeter, as well as corrosion current is a microampere per centimeter square. We've given the different readings. If it is higher corrosion, over 15 microampere per centimeter square. The same way, resistivity also mentioned that. Based on the relationship, we can able to predict the residual life of the structures or corrosion-induced deterioration. The application is it gives the service life estimation to understand that what is the measure to be taken to prevent deterioration early stage, and it evaluating the efficiency of corrosion arresting measures such as application of corrosion inhibitors and membranes and electrochemical removal of chloride from the structures elements. Condition survey of suspected RCC structures, monitoring corrosion activity in RCC structures, and measuring corrosion activity in the repair areas. Once you have the corrosion, you do the protection, the rebar, and finish with the repair. After some time, you can able to check what is the corrosion activity happening through this instrument. We are going to talk about in-place strength without testing core. Nowadays, when the structure failure or any doubts, the Q failure in the lab means what we do? Next, immediately we order for the core testing. We take the core, different part of the structures, and try to do the testing. Many times, we are not getting a conclusion because core testing also involves several parameters affecting the results. Extracting core, first of all, it's a destructive. And not only it's damage concrete integrity, it might affect the reinforcing bar in RCC structures. So try to avoid the core. Taking core always potential damage to the structures. Unknowingly, you can cut the rebar also. Here, I am giving the comparison. What is the duration for the testing of core? First, we do the drilling at core at site and the building in the trimming the core capping, then curing it for 48 hours before testing and crushing for the strength, which is almost takes 1 week. Whereas when you do the cut and pull out test, you have to do only the field test. It's going to take around 25 minutes only. 25 minutes we can get the compressive strength or in situ strength of the particular concrete there. So it will be easy and give the more accurate, and no need to rely upon the your cutting, trimming parallel to the core or whether the curing is done, nothing. On actual side, we can get the in situ strength within 20 minutes. This is the advantage of this. Let us understand. Normally, when you measure in place properties of concrete, ensure the structure will perform as intended. For that, we need to understand the strength. Testing a build course definitely take the many number of courses, taking a time, cost, everything. Alternatively, we can do the rebound number, what we have seen, probe penetration, or ultrasonic pulse velocity. But these all the things require the correlation. Otherwise, we do not get the compressive strength actually. So we can have an indication, but not actual. Better is we can use the pull-out test. We can be able to get the more accurate and reliable estimation on the in situ strength. As per ASTM C900, we can measure the force of pull-out and inserted anchored in the concrete. So we can able to do cut and pull-out test. It does not require pre-planning of test locations. It can perform test any accessible locations. It permits testing of existing structures. Immediate results, as I shown in the first slide, immediate test results compared with the course. This is all the advantage. I can show you how the preparation of the concrete, filling a 18 mm dia hole, almost 65 to 70 mm depth. We can insert the ring in the special slot. Surface preparation done with a diamond edge drilling machine. The smooth surface we need to achieve. Then we need to prepare the special slot special drill is given there to do that. Where we are going to fix the coiled ring, which is going to expand. This coiled ring looks like that. We can able to pull out. When you are pulling out, we will get the break of the V cone shape. Just I am going to show you how the test has been done at the field. There is no audio. We no need to listen for the audio. We can see the video only. The concept behind this pull-out test is the tensile force required to pull a metal disc together with a layer of concrete on the surface to which it is attached. That is related to the compression of the concrete. We are going to convert our pull-out force to the compressive strength. Relatively easy to use. If a relationship established, the method can be delivered robust test results. We have been successfully using this many projects. Even nowadays, the buildings, residential buildings, the consultant prepared to have certain pull-out tests because the damage is very minimal when compared to core extraction. Nowadays, we are working on a lean structural members. The core test is difficult. Paper test being prepared in these locations. Now it's showing the 0, it's set to 0 now, and we are going to apply the force uniformly. So what's happening? The ring which is inserted, it's getting expanded slowly, and ultimately it will break. The ultimate force is recorded in the instrument. Pull-out force. So we have to apply the force carefully, uniformly. That is very, very important to have a more accurate results. Yes. Now it's achieved the maximum force. 38.4 is telling that 38.4 is measured. So if you see that the cone is broken, and we can see the in place also the damage is very, very minimal. We can able to repair with the equivalent strength of concrete motor. The damage is very less. Now I am going to tell you how to interpret this force 38.4. Now here I can show you that the damage is V cone shape we have got taken out from this pattern pull-out test. There is a curve provided. We can say this is a correlation curve. The red indicate for the cylinder and the blue line indicate for the cube. If you say 30 kilonewton, it's around 40 MPa is measured during the curve. Let me see that even we are having the table, we can get the very close reading. 30 means the kilonewton. We are having 39.5 kilotons. These are more accurate. So 39.5 is MPa equivalent to cube strength. So this way we can able to convert the force to the compressive strength. And when you see that, okay, this is all given by the manufacturer as for the ASTM 900, but even I want to believe, so that what I did, I have done a couple of study. I have costed the cube of M35, and when I compare the result of cut and pull out test, the same cube as well as the same group, I did the compressive strength conventionally, so that I can get the closer values. So you can see the value is very, very acceptable, very close. This is one of the things. Second one, what I did a comparison with the core as well as the cube. Now, when I compare the core, wherever I do the capo, adjacent to that, I have taken the core, so that the core value, compressed strength of core, should be matched with the capo test, cut and pull out test. I can see that mostly it's a very, very close, except one a little bit erratic results. So we avoid this result into the group, so that if you see these are two very close. Similarly, when you compare with the cube and the capo, also very close. This all things comes around within the 6% of the accuracy, whereas 8% is allowed as per the standard, so that we are within the limit and giving the more accurate result when comparing with the core as well as cube results. That is a miracle of NDT, we can say. This is a non-contact method, not intrusive method. All the NDTs, you can see that even UPV or rebound hammer, you need to do the surface preparation, smooth and measure it on the surface. This one, you don't need to touch on the surface. We can measure it from far away, 1 mm to few meters or more than that, depends upon the accuracy or resolution of the instrument, infrared thermal imaging. So, do you know IR cameras have been used to detect the leaks in the industries and commercials for a decade ago, and the result is fantastic. We have been using these things, technique, more than 6 years now. We have been providing the service to the industry in a professional manner. What is infrared? There is a spectrum. You can say that there is a gamma rays, X-rays, ultraviolet rays, and visible to the eyes, and some of them invisible to the eyes, but invisible lights converted to the thermal image. Our eyes are now supposed to be able to see infrared lights, because infrared light waves are longer than the waves in the visible spectrum. There is a 8 to 14 micrometer spectrum called infrared spectrum in this one. For understanding easily, the gamma rays, X-rays, we can ultraviolet, visible light, we can see. The infrared, we can able to see through this instrument only. We may not able to see through normal eyes and the radio waves. This is called electromagnetic spectrum. It was discovered by the British astronomer Herschel the way back in 1880. And dispersing a sunlight using a prism, Herschel accidentally found that there was an invisible light on the outside of red light, which increased the temperature of an object. So this electromagnetic wave found by astronomer Herschel. Nowadays, you can see in the airport where the screening is happening because of this COVID pandemic. Every airport, whether it's a domestic or international, we can able to see the screening is happening at arrival to see that who is having the higher temperature. This is not for identifying the COVID or something. It is identifying only the temperature. Based on the temperature, the medical practitioner will take further scrutinizing, screening the patient, or taking the checks for ensuring that they are having high fever or not. That's all. Based on that only they segregate. This is a given example for understanding this principle. Infrared thermal imaging for leak detection is an innovative technology to locate the building leaks accurately in short span of time. Very rapidly it can work. It can provide immediate visual results that can reveal the actual source of the leakages. The hidden building issues can be identified. Even the delamination of the building can be identified very quickly. So how it works? Now you see in the picture, visually the corners looks fine, there is nothing, but thermal image shows that there is an active leakage. Okay, based on the color differentiation helps to detect the type of intensity of the leakage in the buildings. We can able to detect what is the surface temperature. Based on that, we can having a better understanding of the knowledge and the material behavior. We can able to identify the source more accurately. Just a minute. Yeah. So this is how it works. So let us see that there was an interesting case. I spent 3 days to understand the leakage of the swimming pool, which is a very quite interesting case study I'm going to share with you. Now you can see the tower, Iris Tower. There is a 13th floor. There is a swimming pool in between two towers. If you see the close-up view of swimming pool, once it's commissioned, after a month or so, it started leaking. It's leaking from the top. The drop of water is falling from the 13th floor. It's making a hell out of noise. So this from the bottom deck of swimming pool, the leakage is happening. When I got this job, I don't know what to do, how to assess the leakage. When I try to go inside, there is nothing. There is a small trap hole. So we have to enter below the swimming pool. There is only 650 mm distance. We have to crawl down and see that what is there, because there is a deck completely covered underneath. So we cannot see anything, but we can able to see the leakage adjacent the junction of wall in both sides. So we don't know where the leakage is happening. They try to do a lot of measures, trying to grout it on the place. It is not, hitting the right point. How need to be solved? That is a challenge in front of us. So we spent 3 days trying to understand. We tried to ask the history of the swimming pool, how it was constructed. They told me, yes, we have finished the things beginning, the surface preparation, then the spraying liquid waterproofing membrane. It was heavy duty. It's having a more than 700% elongation and tensile, and it's having this proof, fireproof, everything, impact proof. It's an excellent product, and they're also having the protection to the waterproofing membrane, having the what you call geotextile and reinforcement, then the shotcrete being placed more than 150 mm thick. So all the things they have done protecting this membrane. Then they did a ponding for 3 weeks. There was not a single drop leakage found. Everybody was happy. Then they finished it with the China mosaic tiles decoratively. After some time, what happened? They started absorbing the leakage. Its water is falling down. Everybody can see. That has created a big issue for the builder. They are not able to sell the apartments to other people. So when we visited, we tried to identify. We first of all, empty the swimming pool. Try to understand: is there any damage on the wall or inlet, outlet? Everything we try to see. Finally, we can able to find out after understanding and assessing the things. We can able to find out there was one of the outlet having a severe leakage. So this was the source of leakage identified. When you found, we can able to correct it immediately and then successfully completed this. So we suspect, as a investigation agency, we try to suspect all the possible sources of leakage. Finally, we come to the closer, what is the source. Then we give them the recommendation how to do. And when you complete the arresting the leakage, try to do the bonding test, 1/3 height and 2/3 height, and try to understand is there any water dropping, everything they have done systematically. Finally, they succeed. This is a completed job. After that, the client is very happy to see that still they are taking our help in case of any critical issue on this similar manner. Now, already time is up. I am coming to the conclusion now. If you want testing the mechanical properties, if you want to know the compressive strength, we do the core test or rebound test, pull-out test, or Windsor probe test. If you want to know the quality of the concrete, we can use ultrasonic pulse velocity or impact echo, impact pulse response, etc. If you want to know the tensile strength, you can use the pull-up test or splitting tensile strength. The repaired surfaces, if you want to know the bond test, you can use pull-up testing to understand the bond strength. Similar way, even the chemical properties required to know it is supplement to the corrosion-related issue, carbonation-related. If you want to know the electrochemical activity, the corrosion activity, you can do the optional potential, electrical resistivity, rate of corrosion. If you want to know the carbonation depth, you can do the simple Planck test to understand the depth of carbonation, and petrography examination, infrared spectroscopy to understand the carbonation level. Alkali aggregate reaction or alkali silica reactivity, you can do the petrography examination to understand the parameters. Chloride content can be get through the chemical analytical method to understand the chloride ingress, chloride presence in the concrete, which is mainly attributing to the corrosion activity. How to interpret the result? If you are having basically the common test like a UPV, rebound AMOS also, this will be misleading sometimes. You are not doing the interpretation correctly. When you get the high UPV, high rebound number, it may not be more corrosion. If you are having a medium ultrasonic pulse velocity with a low rebound armor, it could be a surface delamination or low quality surface concrete, or this may be corrosion prone zone. We need to assess with the more NDT techniques. Low UPD, high rebound armor. It may not be a corrosion prone, but chemical analysis and carbonization required to understand the carbonation level depth or the corrosion activity. Low UPV and low rebound definitely is a corrosion prone. Chemical or chemical analysis required, and carbonation tests also required to assess this quality. Similarly, based on the cover thickness and corrosion risk, adequate cover thickness is there with a good quality concrete, relatively that may not be corrosion prone. Adequate cover and the bad quality concrete combination is a corrosion prone. Less cover thickness, even with a good quality concrete, it's also corrosion prone. So we need to go further test to ensure what is the corrosion activity, what is the possibility or probability of corrosion. Like that, we result. The availability of wide range of non-destructive testing equipment has made it easier to monitor quality or discuss or durability of concrete structures. The non-destructive testing instruments proved to be reliable and invaluable. However, interpretation of this is a required competent person to arrive at acceptable evaluation of concrete regarding its quality and strength. Diagnosis of defects and condition assessment are essential prerequisites for a successful concrete repair. Without assessing, if you start the repair, there is no end to it. We will be doing it again. If you want to identify the issue and the depth of the deterioration, you can do the successful repair. Before concluding, don't replace, repair in place. I want to give the message towards the end of the presentation. Thank you very much for listening patiently. I will request Mr. Anil Pillai take over, please.
Thank you so much, sir. It was a very good presentation. In fact, you had covered on various aspects of NDT testing, because starting from rebound hammer and then the corrosion-prone scenarios, that was really interesting, because it all boils down to the fact that we need to make a structure which has a longer service life, and higher durability. Right. And at the same time, even there is a problem, even the swimming pool example was very interesting, because once a problem crops up, it's very difficult to find out how it is coming and where it is coming from. That is really a very challenging thing.
Because I have not narrated the story, because due to loss of time, I cut short that thing. Otherwise, we would have spoken even 30 minutes for that exclusively.
Yeah, I understand, because understanding the source of the problem is very difficult, because sometimes, we jump to conclusion, saying that either a workmanship practice, material problem, some problem, and then we stop it there. But we do not go to the root of the problem. I think the root of the problem is what is required.
Yes.
One question which is being asked is, what is the name of the instrument used in measuring the depth of the cracks? It is being asked by Mr. Vadiraj Rao.
That is the ultrasonic pulse velocity equipment. This is the latest release, so that you can able to find it. In case anything, let me help you to that. This is a recent developed instrument.
It's an advancement over UP ultrasonic pulse velocity test, is it?
Yes. Yes.
Because even in Rebound hammer also, you were talking about the Q value and the R value. R value was the earlier. Q value is much better.
Element. So this all the things is because everybody knows the rebound hammer or UPV. These are the basic and common things everybody use in day-to-day professional life. But what is advancement happening? What is the latest things? That's why I have taken this subject. Otherwise, normally it's most familiarity. But what is new? That's why I have taken this subject to explain a little bit.
One more question is that, can we assess all the properties of concrete? How many properties of concrete can we assess using rebound hammer test?
No, rebound hammer test, generally, I can tell you, we can measure the surface hardness. Based on the surface hardness, if you are having a correlation properly or empirical correlation, we can able to assess the likely compressive strength. Nowadays, there is a technique level developed. From the ultrasonic, the second sonic and rebound hammer, they taken rebound hammer, the Sonrab technique. They use rebound number and ultrasonic pulse velocity. There is a correlation developed by the manufacturer, so that you can predict the reasonable compressive strength. So there are several methods. If there is any specific, let me help you on this.
You can combine both, you are saying, to get a better idea. One question by Ms. Soumya Srinivasan. She wants to know, is there any method to check the structure with liquid retaining before even using it, just to check for using it, not the ponding one? Any other test other than ponding to check the effectiveness of liquid retaining structure?
Bonding test is a conventional and foolproof. You can able to see, everybody can able to see. At the same time, the bonding test also sometimes gives a successful result, like whatever shown in the case study. But in the practical, because of the lot of other parameters influencing, like water pressure and the holding for a longer time, this all the thing created. The bonding test normally we do 100 or 150 mm 48 hours. It may pause the test, but more than the bonding is actual, that is a reality test actually. Normally there is the pressure test, this test, bonding test conventionally to prove that there is no leakages happening, there is no defect. But more than that, in a practical usage, normally I used to tell that in the buildings also, you see the first monsoon where the problem is coming, then we can be able to address it clearly. It's not really what we can certify before, start using it. So conventional methods are powerful tool.
Because there is another question related to this. Someone was asking, leakage is one thing, but dampness, why does dampness come? Sometimes it dries off, but is there a particular remedy for dampness?
Leakage is happening because the water is seeping through and dripping. That's the leakages. But other side, the concrete is having a lot of impervious or non-permeable, so that the water is not dripping, but moisture is spreading out. We call it a moisture movement. So moisture can create a lot of problem, fungus or health issues, or we can see the peeling of the paint and delamination. Slowly it's effectively taking into the corrosion. There is a lot of issues can happen, moisture present along with the reinforcement. So equally, when you are seeing the dripping leakage, that's a very serious issue. But even the dampness, we should not be taken lightly, even though after some time. So we need to find out the root cause to prevent it, or preventing from the moisture surface or any other water sources. We need to address it severely.
Is there any remedy for that? If dampness comes, any remedy for that? Any remedy for dampness once it is seen?
Lot of remedial solutions available. Depends upon the nature of the problem. One is we need to understand is entering. That's why the reflected as dampness. So we need to see that, to find out the source and to prevent. That is the way we have to do it. Whereas if we talk about the method, there are several methods available. Methods or injecting certain materials or cementitious. There are a lot of methods available.
Mr. Uday wants to know, is there any code or guidelines for the old building or structure and rehabilitation process?
Sorry, I couldn't get your question clearly.
What Mr. Uday wants to know, is there any code or guidelines for old building or structure and rehabilitation process? Any codal provisions are there?
There is a ACI 228. It's talking about structural assessment and providing the remedial measures. Unfortunately, there is no code on Indian standards. We follow a lot of ASTM as well as ACI code. ACI is currently we are following that, to understanding the assessment of the structures, the repair, rehabilitation, and even selection of the material for repair. Nowadays, EN Standard 1504 has released to selection and protection of the structures, even the quality control. We can follow EN Standard 1504. There are several parts available. You can take a reference. 1 to 10 part is there. You can take a reference of that.
Thank you so much. It was a very interesting presentation. I think many of the professionals could gather so many points. Let me invite Mr. Mrityunjay Kumar to give the vote of thanks. Mr. Mrityunjay, you are there?
Yeah.
Yeah.
Am I audible, sir?
Yes, you are audible. You are very much audible.
Good afternoon, Honorable Engineer Anil Kumar, sir, GM Technical Services, Ramco Cements Limited, Engineer Suraj Kumar, Engineer Suresh, and our most valued invited guest, crew member, and whole participants. It's my privilege to have been asked to propose a vote of thanks on this occasion. I, on behalf of Pidilite Industries Limited and on my own behalf, extend a hearty vote of thanks for gracing your important work and honoring us on such an innovative platform for the spread of knowledge and awareness among the societies on different aspects of latest technology in the civil engineering field. A big thank you to Engineer Gopalkrishnan sir for his effort toward non-destructive evaluation of reinforced concrete structure, non-destructive testing method, and sharing with us your feelings and opinions today. It's really important in this T20 world where everything is required immediately, and hence different testing method of NDT or detection of critical water flow leakage with 100% accuracy and also with rapid speed through technologies are becoming a need of everyday life. Thank you very much, sir. Thanks for your invitation to us, and thanks all participants for the
Thank you so much, Mr. Mrityunjay Kumar, and thank you, Mr. Gopalakrishnan, and thanks, Suraj Kumar, thanks all the participants, and if there are any queries, we will send it to you by email, sir. Thank you so much.
Yeah, I displayed my email ID as well, so please, they can pose the question through you or me directly, whatever they like.
Sure.
Thank you for organizing. I'm thanking you once again to Ramco as well as on behalf of Dr. Fixit Institute and Pidilite Industries for collaborating this event. I'm thankful to you.
Thank you so much. I think NDT testing will